All right. Okay, chapter 3 or chapter 2 here written, yeah, process concept. So, so this is the hardware or PC block diagram, yeah. So I think most of you are very familiar about this, yeah, architecture. So I think we need to explain more on that. So we are computer scientists. We already knows this very well, yeah, about PCI, USB bus, and so on. Okay, all right. So definition, a process, yeah. What is a process? Process is an instance of program execution. It is an active entity. Two processes may come from the same program. However, their execution are different. Therefore, each one is a different process. For example, if two users are running a word processor, two processors will be created. Okay. A program is a passive entity whereby it comprises of program coding, which is a static entity. Therefore, a program itself is not a process. Okay. Component of process. First, program code. Second, context of program execution. Content of CPU register. As we know that, okay, in micro P class, we already know this some registers, yeah, and also in OS also class we learn this, yeah. So content of CPU register, for example, register and also some program counter. So these two are the register, yeah. Other information needed by the operating system, for example, state, yeah, process state, and also scheduling. Okay. Third things, program data, which is in stack, store temporary data, for example, subroutine, parameter, local variable, and also some return address. And some global variables. This is some component, yeah, of a process. So this is the, I think, basic diagram of our machine. Yeah, we have input device, and we have output and baking storage, and this is the processor. Okay, we have CPU, control unit, ALU, arithmetic logic, and also main memory. So process states. Process states depict the current activity of a process. When a process is executed, the process will change from one state to another. Changes states after an event occurs. A state transition diagram can tell what event causes a process to change state. We have a process state model, yeah, 2-state and also 5-state model. Process with 2-state model, a process can be in one of the following state, yeah, running and also not running. State transition diagram, yeah, we have not running, okay, from first state not running, after running, okay, we dispatch and then they will change from not running to running, and also pause from not running, from running, pause, which is this one should be back, point to the back, yeah, point to the not running state, yeah, and then exit. Okay, this is a state transition diagram. Okay, 5-state, we have new, running, ready, waiting, block, and exit. Okay, so this either two state, okay, one we call 2-state model, and 5-state. 5-state, you can see new, the process is being created. Running means instructions are being executed. Ready means the process is waiting to be assigned to a CPU. Waiting and block, the process is waiting for some event to occur, example I/O completion. Exit, the process has finished execution. Okay, because of this state, okay, we can see here compared to this, okay, our machine, yeah, especially our computer architecture, we can run this parallel, okay, because of this, we have a state of waiting and block. Okay, we should stop the one of the process and then let others and so on. So in order to implement that parallel computing, so that's why this state model is very important. We need to know that. Okay, that's why we learn this state. Okay, different operating system, a different name of the state, of course. Yeah. Okay, so 5-state model. This is a state transition diagram. Okay, we have a new and admit we are in the ready state, and after that we go for display, they will change to the running state, and also terminate, they will execute, and also from running to wait, they will event waiting instruction, for example, and also there is a running to ready, which is interrupt instruction, for example. Okay, from waiting to ready also there is some event occurs. Okay, so it will change from one state to another state. Okay, so this is 5-state model for the process. Yeah. Process control block, PCB. Each process has a PCB. Yeah, process control block. PCB PCB stores information related to a process. Yeah, content of PCB. Process identification, numeric identifier that may store with the process control block include identifier of this process, identifier of the process that created this process, and user identifier. Okay. Okay, processor state information. Okay, first, processor state information, we have general purpose register and general control and status register, which is for program counter or PC. Program status word PSW, which is condition codes and execution mode, and stack pointers. C, process control information. Process state, scheduling information such as priority, amount of time executed, the last time, memory management information, for example, pointers to page table, resource ownership and utilization, data structuring, yeah, parent-child relationship, link to other processes in a queue. Operation on process. Generally, OS needs to provide a mechanism for process creation. A process can create another process, yeah. Remember that fork, yeah? Okay, that's another instruction to create a process. A process which creates another process is called a parent. The process being created is known as a child process. Every new process can create another process. Okay, this is basic. When we create this another process, so there is a parent and also child. Okay, I think in object-oriented, you also learn about this. Yeah, we have different terminology. They use base, class, yeah, base, and also I forgot that. Yeah, base, class, and also what we call that when you create the rest. So here they use a child, yeah, parent and child. Okay, process termination. Process should be terminated when the program terminates. Process creation. Process involve assign a unique process identifier, keep the process information in a process table, create a PCB, yeah, allocate space for the process. Reason for creation, submission of new batch job, user logs on to a computer system created by OS to provide a service such as printing, spawned by existing process. Process termination, reason for terminate is program has completed, user log off, quit, an application error and faulty condition, memory unavailable, protection, arithmetic error, for example. Parent termination or parent request. And then operation in process termination, like data is returned to a parent process and deallocate resources. Okay, there's some reason for this process termination. Yeah. Context switching, changes in information when CPU is switched from one process to another. Okay, store the current process, state for the process that leaves CPU in its PCB. Load the state of process that is being allocated CPU from its PCB. Okay, time taken for context switching is considered a system overhead. The speed varies from machine to machine, depend on the memory speed, the number of registers that must be copied, and the existence of special instruction. Typically, speed are a few milliseconds. Context switch between two processes. Okay. Executing, okay, P0, and this one is P1. Okay, operating system. At the beginning, they save into PCB, they're running this. And then at this stage, they're running PCB 4.1, so they need to change. Okay, they need to point to this PCB. So that's why they have to they do this context switching, because the content PCB, PCB of each of the process need to be uploaded to the memory. Okay, in order for execution of the process. All right. Okay. So when to switch a process, okay, clock interrupt process has executed for the maximum allowable time slice. We have I/O interrupt, memory fault. Okay, memory address in virtual memory, so it must be brought into main memory. So we need to do switch, switching contact, trap, error occur, may cause process to be moved to exit state. Also, supervisor call, such as file open. Okay, this is when to switch a process. So this is the activities that we need to do the switching. Cooperating processes, concurrent processes can be independent processes, cannot affect or be affected by the execution of another process independent. Cooperating processes can affect or be affected by the execution of another process. Okay, means here, okay, like calculation, sometimes we need some independent, okay, we need to complete the calculation before we pass the result to the following processes. That's why we have issue of independent or this one, cooperating, independent or non-independent. Okay, cooperating means for dependent processes. Advantages of process cooperation: information sharing, computation speed up, modularity, convenience for editing, printing, and compiling. Concurrent execution requires process communication and process for synchronization.